Hello, my name is Qiu Yang. My teammate is Peng and Ying. Our project is Otto Group Product Classification. In this video, we'll first describe the motivation of our project. Then, I will introduce you different algorithms we will use to process the data and compare the different algorithms. Finally, we will show you the demo of our program. The Otto Group is one of the world's largest e-commerce companies and sells millions of products worldwide. Every day, there are thousands of products needed to be added to a product line, and they need to be rightly classified to different categories. Due to the diverse global infrastructure, many identical products get classified differently. The quality of the product analysis depends heavily on the ability to accurately cluster similar products. The more accurate we classify the products, the more insights we can get about the product range. The dataset we use for this project is a file that contains more than 200,000 products. Each product will have more than 93 features and a label describes its category information. The dataset can be downloaded from the category website. We'll use a training data.csv and test data.csv. However, since the test data does not have the category information, we will randomly split the training data into two sets, training datasets and testing datasets. The data field of the file contains an ID, which is a unique identification for a product, and features from feature 1 to feature 93. They are numeric values of the product, and the target, which is the category information of the product. To pre-process the data, we divide the dataset into training and testing parts. 90% of the data is training and 10% of the data is testing. We generate 10 sets of training and testing data. We also use a scaler to scale the features of the product. And what's more, since the label of the product is a string like class_1, we will transform the string into integers, like class_1 was transformed to 0, class_2 was transformed to 1. The algorithms we use are random forest, neural network, and extreme gradient boosting. And finally, we will combine the result from previous three algorithms to produce a new result. Random forest is a notion of the general technique of random decision forests that are an ensemble learning method for classification, regression, and other tasks. They operate by constructing a multitude of decision trees at training time and outputting the class that is more of the classes or mean prediction of the individual trees. The random decision forests correct for decision trees' habit of overfitting to their training set. And in our project, the library we use for random forest is sklearn. The neural network is presented as a system of interconnected neurons which exchange messages between each other. The connections have numerical weights that can be tuned based on experience, making neural nets adaptive to inputs and capable of learning. In our project, two libraries called Keras and sklearn will be used to implement the neural network algorithm. And XGBoost, which is also called extreme gradient boosting, it's an implementation of the famous gradient boosting algorithm, and it's often described as a black box. It works well, but it is not trivial to understand how. And this model is made of hundreds or thousands of decision trees. In our project, I will use It also uses sklearn package and the GraphLab Create framework to build the XGBoosting classifier. To evaluate the result, we need an evaluation formula. Here we use the log loss. Look at the formula. Yij equals 1 if product I belongs to category J, and Pij is the predicted probability that the product I belongs to class J. So the smaller the log loss score is, the better result we achieve. We can look at the log loss table. We found that the XGBoost achieved the best result among 3 algorithms. The average log loss is 0.46, while the worst result is from calibrated random forest, which is 0.48. After we combine the results from 3 different algorithms, we get a new result. The combination achieved the best average log loss score, which is only 0.446. And here is the general information of this project. And let me show you the demo of our program. I'll first show you the dataset we use for this program. So we'll first show you the training dataset. Since we split the data to 10 different datasets, I will just show you the first dataset. This is training data. As you can see from the column information, there's an ID, a target, and 93 different numeric features. The first product belongs to class 1, and the features are basically integers. The training dataset is almost the same format with testing dataset without the target label. So the training dataset has the ID of the product, the 93 features of the product, but it does not have the category information of the product. That's what we want to predict. And we also have the actual label information or actual target information of each product. It corresponds to the testing dataset. So, since the random forest algorithm and the neural network algorithm, we do not output intermediate result. So I will simply show you the how to run the XGBoost algorithm. As you can see, it starts to training the model of the XGBoost classifier. And I set the iteration to 500, and for each iteration, it will refine the previous model to achieve a better accuracy. The first iteration, the accuracy for the training data is only like 0.75, and the accuracy for validation dataset is only 0.771. However, when you see that when the iteration goes up, the accuracy also increases. Since there are 500 iterations, it takes too much time to complete this process. So I will just interrupt it. And the final accuracy we can get for the training data will be more than 98%. And for each dataset and each algorithm, we will produce a prediction file, which is the result of the testing dataset. So I'll show you the result for the XGBoost on the first testing dataset. The result, the format of the file is like this. There are 9 columns, which means the column I means the product, the possibility, the probability that the product belongs to category I. So the first product, the probability belongs to to category 0 is only 0.69, and you see that the probability the first product belongs to category 7 is 0.7. So basically this is the most possible category that the first product belongs to. So here's the basically the demo of our program. And random forest, neural networks, XGBoosting are 3 most popular algorithms to learning the multi-label classification. And XGBoost actually achieved the most accurate result and require less time to learn and fit the to predict the result. And thanks for watching the video.